Hello everyone, welcome back to IAPT Global, and in the last video we saw how to create or how to configure an S7-1200 PLC as a Modbus client, Modbus TCP client, and we saw how to read a data from a Schneider M221 PLC. So in this video we are going to see how to configure the Siemens PLC again for the Modbus TCP read with the Allen-Bradley PLC, that's a Micrologix 1400 for both reading and writing. Okay, so let's create a new project. So let's say quickly create a project. Okay, so from the Siemens side, so this is what we need to do. We'll quickly create a project view. Okay, let's say add new device. S7-1200 CPU 12, let's say 1215C DC relay is the model that we use. Okay, yeah, so now let's let the PLC start. So in this video I will also show you how to configure the Allen-Bradley for Modbus TCP as well. It's a very quick function, and you have to make sure that please have a look at the Allen-Bradley Modbus TCP videos to get the complete understanding of Modbus and the Allen-Bradley Micrologix system. So next, only allow next, full access, and next, and finish. Okay, so now few things. First and foremost, we need to change the IP address because the IP address that we are using is not the default one. So 11. Then on the PLC, we need to enable the system and clock memory. Then that's it. So now let's go to the program blocks. Main block. So this is the setup on the Siemens. There is nothing special here. That's it. Okay, now on the Allen-Bradley side, let me just create a new project. Go offline. No. Let's create a new project. So yes. So the PLC I am using is a Micrologix ML1400 Series B. Quickly we will create it. So major thing, I need to set up the channel configuration. So channel 1, boot P disable and enable Modbus TCP. Give the IP address. So the PLC that I have is running in 192.168.0.4 with the subnet of 255.255.255. Okay, then apply. Okay, then again go into channel configuration. Go to the channel 1 Modbus here, and we need to create some holding registers for our Modbus. So on the, if you are familiar with Allen-Bradley systems, you already know there are data files for all the data. So I am going to create a data file specific for the holding register, and I say I want 100 registers for the 4 series holding registers. Okay, and give apply. So it will ask me, sorry, not 100. No, I want the holding register to start from 9. So we have up to F8. We need 9. Apply. So I want total of 100 registers. Yes. So now you can see we have created a data file called as holding register, inside which we have 100 data. Which we have 100 data. Okay, let's quickly download it. Download. So let's say Modbus TCP. Yes. So now it's done, and let's give this. Now it's gone online. So now if you see at the holding register, you can see some registers are getting written from the old program that I have. Okay, but we will change this now. Okay, so we can see 10 into 10. So from 0 to 9, then from 0 to 90. So you have 100 registers in total. So next what we are going to do, we are going to the TIA portal. So very quickly we will add like the last time, we will add a Modbus read block. So let's go to communication, others, Modbus TCP, MB client. So let's put the MB client here. Okay, so first we will quickly read and then we will go for the write functionality. So the enable, let it be there. So the request can be, let's say I want M0.5, that is the first 1 Hertz clock. Then I have the disconnect function. So I'll give a dummy address M10.0. Then I have the MB mode. So I'm going to read the data. So the MB mode will be 0. If you remember from last video, the data address I'm going to read is 40001. So data length I'm going to read is 10 data registers. So if I want to read 10 data registers, I need to give a MB pointer, that is an array, and I also need to create the connect block. So let's create the new blocks, add new block. Let's say create the MB connect block, MB underscore connect. So any name you can give, I'm just giving MB connect. So let's say connect 1. So this will be tcon underscore v4 underscore IP. Sorry, tcon IP underscore v4. Tcon IP underscore v4. So this is the data type we want to use. So here the interface ID will be 64. So this can be found from the device configuration. So in the system constants, and if you click on the Ethernet port, it will show you the interface ID, that is the 64. Okay. So MB connect block. So ID means the first ID. So this is the first instance. Connection type can be same, no need to change. Active established can be true. Then we have to give the IP address of the slave or the server. So it will be 192.168.0.4 if you remember. Now the remote port will be 502 and the local port will also be 502. So let's go to the main block again. So the main block, let's click on MB connect and drag and drop the connect one here. Done. Now we are going to create one more DB, that is the Modbus data. So I am going to create another DB called as Modbus data. So in the Modbus data, you have to remember, you have to remove the optimized block access. You OK, and here you give MB underscore read. So data type is going to be an array of integer, but I am going to need 10 data, so 0 to 9, so which will be 10. So you can see here there are 10 data here from 0 to 9. Let's quickly compile this block. This is very important. Once you compile, you will get the offset. Yes. So now let's go to the main block again. Click on the Modbus data here. Drag and drop the pointer into the MB data pointer location. That's it. Now, most important, you need to add this. This is very helpful. So client DB. So let's say done. And I want busy. Client DB, let's say busy. Error. And finally, status. Client DB status. Where's the status? Status here. Okay. So now let's quickly compile it and give it a download. So I'm giving a half-second pulse to continuously write the data. So let's download it. Download. There is no errors. So once it's compiled, we can directly give download. Let it show up the PLC. I'm waiting for the PLC to show. Yes, we have a PLC. Load it. So 0.11 is actually the PLC that I want to use. So both are same. So in the lab we have multiple PLCs and I want to download to this particular PLC. Continue without synchronization. Stop all, load. Finish. Okay. So now you can see here. Let's go online. We should be able to see the data. So we are going to read the data from the PLC, from the Allen-Bradley PLC. So you can see it is giving a 456 status. That means it is receiving data from the slave. Let's go to the Modbus data DB. Open this and we can see the monitor value here. Let's open the Allen-Bradley software on the side. And whenever I change something here, 10, 20, you can see it is immediately reflecting there. Up to 90 you can see, and there is on the 10th element, okay, let's say I put 100. So you can see the data is reading from the Allen-Bradley PLC very easily. So these are the old data. Okay, you can see from 10 to 100. So if I change this to 55 for example, you can see it is changing to 55 as well, right? So this means that our read function is working well and good. So now we are going to try to do the write function. So we are going to write to the next 10 registers, that is from 400102 to 400112 to 40020. Okay, so let's go to the main block. So if you want to do the second block, unlike 485, you can just drag and drop another MB client block. So that is the advantage here. You can just drag and drop another MB block. You don't have to worry about having the same DB or anything. Okay, so here the request, I will put the NC of this functionality. So NC of the M0.5. Disconnect, I can say M10.1, just a dummy address. MB mode is going to be 1. MB data address is going to be 40011, that is the 11th address. And I'm going to write to 10 devices. So I need another data pointer. So let's go to the MB data block. So let's create one more data called as MB write. So same array of 10, right? So let's just give it a compile to create the offsets. Then once that is done, go to main block, click on MB Modbus data, drag and drop the write into the MB data pointer. Now you need another connect block. This you have to remember that. Okay, this connect block is different. Go to the MB connect data block. So let's create a connect to block, connect to data. Let's take on IPv4. So here you have to do one major change, that is interface ID is same 64, but the ID is going to be 2, connection type same, active establish is going to be true. Then we have the IP address, same address 192.168.0.4, same 502.502. That's it. Just give it a compile as well. Now go to main block and from the MB connect drag and drop the connect to the connect block. So again here you can put up the errors and everything. MBDB1 done, busy, again the error, and finally the status, right? Okay, so let's give a download. So let's see what is happening. So initialize, load. So there is no COM load or anything like what we do in RS485 here, because the data is directly initialized from the MB client block itself. So this is very, very advantageous in many situations. Okay, so now you can see here. So this block is still writing. So for example, let's say I go to the MB connect block. So the MB Modbus data block, it's still reading. So let's say I want to change something here. Okay, I want to change this to 11, 22 it's working, 33 it's working, 44 it's working. Now I'm going to write from here so that it will reflect onto the Allen-Bradley. So let's say, where is the monitor value? So I say I want to put maybe I want 12 here, but nothing happened. 13 here, nothing happened. 1 second. 13 here, but nothing happened. It is not moving here. Why? Let's check what is the error. Okay, so let's go to the main block. If you see here, your write block is giving a data status of 5 and 6, 7004, 7005 and 7006 6. This is normal operation, but your write block is only giving, write function is only giving a 7002 or a 7001 result. So let's see what these results are first. So let's open the help and go to the status functionality. Scroll down, status, good. So you can see 701 means connection establishment is triggered. 7002 is intermediate call, connection is established, but you are not able to, that you can see the write block is not giving the 7005 or 7006 data. Similarly, 7004 data is status is also not being repeated, given. This is because the problem is when one MB client block is enabled, the other MB client has to be disabled. Okay, so the easiest way to do is by disconnecting the block, not by enabling or disabling the block, because sometimes the connection request might be still active. So it's better to disconnect the block. So how to disconnect the block? So it should disconnect when this block is active. So when will this block be active? When this NC is active. So I will put a NC of the M0.5 here, M0.5 here. So whenever this block is active, this block will disconnect. Similarly, whenever this block is active, okay, that is whenever this block is active, this block will disconnect. So that is the NO. So it will alternatively work. Okay, it will alternatively disconnect and get connected. So it will not give any errors. So let's say compile it, download it. Let's see whether it is working or not. Okay, so now you can see. So you can see here 7005 6. Here also you can see 7002, 7005 or 6. So meaning that both the blocks are now communicating properly. So if you go to the Modbus data block, so you have some data already present, and you can see whatever data we wrote earlier also got written into the Logix 500. So you can see, let's say I want to change this to 565. So you can see it got updated here as 565. So if I change this to 789, you can see it immediately changed to 789. So you can increase the frequency of this data transmission by up to 100 millisecond. But if it is too much data, if you are sending too much data into the system, it's better to have at least a delay of half a second to 1 second between each successful transactions. Okay. So this is how we read and write using Modbus TCP without any errors in the S7-1200 PLC. Okay. So for example, if you have more than two blocks, then you can use a count block and a pulse to count. Then you can disconnect it as per required whenever it is not equal. Then you will be able to do that as well. So let me give an example as well for that maybe. So if I want to read data from another Schneider PLC, I can show you that the data can be read or written. Just give me a second. Let me switch on the Schneider PLC. Then we will talk. So now the Schneider PLC is switched on. Let me open EcoStruxure. EcoStruxure is the software for Schneider. So now we are going to communicate with two different PLCs in Modbus TCP to get data here. Okay. So let's see how to read the data from there and see, like, just to read the data and see how it is happening and how to implement the counter functionality as well. So let it happen. Yes, okay. So now, okay. So inactive, choice continue, to inactive, apply, go to commissioning, and you just log in and you just upload, because there is already a program there. You might remember from the last video. So if you go to the programming, you can see here. So there are some data already there. So I can see 40001 with a value of 45 already there. So let's try to read these 5 data, 1, 2, 3, 4, 5 data, not the 6. Let's read 5 data along with this. Okay, so this is already running. So let's go to TIA very quickly. So what we have to do, we have to create one more Modbus client block. Okay, it could be multiple instances, it's not a problem. So you have to create a connect block as well. So let's say I want to create connect 3, connect underscore 3. So same tcon vp-i4. So same thing, hardware ID 64, but the instance ID will be 3, true. Then the IP address will correspond to the IP address of our Schneider PLC. So 192.168, sorry, 2.168.0.18.502.502, done, right? So now just quickly give it as a compile. Similarly, we also need to read 5 data. So let's go to the Modbus data registers and let's create a MB read underscore M221 PLC. So instead of array of 9, let's say array of 0 to 4. It will give us 5 data exactly. Compile it. Now go to main block, Modbus data. So Modbus read will go to the data pointer. So similarly, the connect block is going to the connect. Data length is going to be 5. I'm going to read, so it is 0. MB mode is going to be 0. So the request, how to give the request? Let's say I will show you how to create the request now. So let's do the done quickly. Done. Okay, so let's copy till this. It will be busy. Error status. Okay, so everything has its own status blocks and everything. So what we are going to do, we are going to create the timer functionality, that is a counter functionality. So let's go to our basic instructions, counters. Let's put a CTU. So let's create it. So we have 3 blocks. So the PV will be 3. So it is going to count based on the M0.5 pulse. And here you can see the reset is going to be based on the done bit of this counter itself. So where is the counter? Counter QD. That's it. Now you got the PV and everything from here. So now what we have to do is we have to change all the functionality here. So the request has to be done through a compare function. The request has to be done through a compare functionality. So let's go to compare. Let's say where is the conversion? Compare. So if it is equal to, so if this is, let's say, when the counter's value is equal to 0. So counter CV is equal to 0. Then this should work. So same thing, copy. Should be. So when the value is 1, this should work. And when the value is 3, sorry, when the value is one second, so equal to, so yes, the value is 2, this will work. So when it will disconnect, whenever the value is not equal to this value. So there is a not equal to function. So same thing, okay, but it is not equal to. So see, so whenever it is not equal to 0, it will be disconnecting. When it is equal to 0, it will not disconnect. Whenever it is not equal to 0, it will disconnect. So copy this, paste. So here whenever it is not equal to 1, it will be 0. So here let's put a dummy. Now it is value is 2, this will become disconnected. Okay, so now we have 3 MB clients. We have 3 MB clients. So let's see whether it is working. So we are going to experiment on this. Download it. Yes. So let's go online. Let's see on the Allen-Bradley, we have now, as of now, 000 these things. Let's go to our Siemens and be Modbus data block online, and you can see here. So let's say I want to read some values. Let's go to main block. Okay, the counter is now at 33. Why? Okay, so that's a small mistake here. Sorry, it should be QU. So small mistake on the program. True. So there's a 8189 error happening. So let's see what it is. 8189. Let's say 7005. Okay, this is good. This is also good. But for the Schneider, we are getting a small error. That is an 8189 error is happening. 8189. So let's find out the Modbus data now. So this is, I'm reading it properly from here. So let's say I want to write 52, 65, and say 145. So this should be written onto the Allen-Bradley. Let's say yes, it is written onto the Allen-Bradley. Okay. So now we are getting a small error on the block. So let's find out what is the error. So let's say I want the MP connect block. So the instance is 364 true, 192.168.0.18. Let's just check whether it is 0.18. Yes, this is correct. So there is no problem here. Configuration, Ethernet, Modbus server is enabled on the Schneider side. So what could be the problem? Let's find out. So the problem, let me see, it's giving an 8189 error. So let's go and check the help. So if the error is 8189, it means invalid addressing of the data at the MB data address parameter. Okay, MB data address parameter is wrong. Okay, so maybe there's a small mistake on the program. Okay, so yes, sorry guys, 40001. So this is the address we are trying to read. Okay, so we have to give this address. So this was the error. So I did not notice the error. So we can most probably find any issues based on the error code you are getting on the status. Because 0 is not a valid Modbus address at all. So it has given, yeah. So now 1, 2, yes, 7003. Good. So you should be now getting the data. You can see yes, 45, 65, and nice. So on the programming part, so let's say put it on the side, let's put it on this side, minimize this, zoom it a little, and show it to you guys. So okay, it's now 45. So I want to change, make this to so this side monitor value is 45 now, and I want to make this as 789. So in 1.5 seconds it responds, okay, because it's the third instruction in the list. So in 1.5 seconds it will normally respond. So I can maybe change this. Last address is 0. Let's say I want 4578. Enter. Oh, sorry. Yeah, it's already written on the address 104. Okay, okay, sorry. I'm reading only 0, 1, 2, 3, 25, 78 is there, 789 is there, 789. Okay, I think we have done another small mistake on the program. I'm reading only 5 datas, 40001 to 40005. Okay, so the program is having some issues, but still, yeah. So we are able to read the data here. We are able to read the data here. Okay, so yes, 789. Yes, 457, 65, 78. Yeah, it's updating. Okay, so I think this program on the Schneider side is having some problem. 5. So let's say 1245. 1, 2, 3. Yes. Yeah. So maybe this register is having some issue, but it's not. Yeah. So the problem is here because this is a different register. You can see here. I'm only reading properly from here to here. So these registers are wrong. That's why I'm not able to read it here. If this is MW3, then this will be proper. Yes. So the mistake is not on the Siemens side. The problem is on the Schneider side. So we are actually reading the first three data properly. Yes. So this is how we use a Modbus client block in Siemens S7-1200 PLC to read and write and read from a second PLC or from another Modbus device at the same time. Thank you.